So thanks for coming, everybody. Tony is the head of our compute sector, and he's definitely the expert on JupyterHub and all things compute at Quasi. So he'll be presenting today.
Thanks, Claire. Yeah, so we will be talking mostly about a JupyterHub computing environment we have that we maintain for the community, but I'm going to give some slides to give an overview. I'm sure you already know quite a bit about HydroShare and some of the things I'm talking about. So I'm going to plan on breezing through a little bit of that, some of the background info, but feel free to interrupt me if you have any questions. And then we'll just do some demo play around at the end so you get a better feel for what exactly the cloud computing services we have can do for you. So this is one of those core HydroShare slides I'm sure you've seen, but just recognizing that HydroShare is a data repository, holds all sorts of different types of data, and not just data, but it can also be code or model related, like inputs, things like that. But it's really just focused on that data archival, and there's so much capability built into sharing and accessing control and such. Making use of these data in the cloud has been made possible via web applications, and that's what we're going to talk about today. So if HydroShare is the circle guy on the left, we have HydroShare resources, and we're looking at one here that's exploring data for the Lucio CZO. This is actually, I don't know if you know, Miguel Leon's file that I've cloned and modified for a demo in the past. And this lives in HydroShare, and inside of there is a Jupyter Notebook. So if I want to use that Jupyter Notebook, and for anyone that maybe isn't aware, Jupyter Notebook is just an interactive way of writing code. And you can write in your browser. It's a nice way of combining code with like narrative, great for education and also for like scientific dissemination. But we have this HydroShare thing here on the left, and we have these resources. And I guess I should probably take a step back. You don't actually have to have a resource that has code in it to work in different web applications. It could just be a data set, CSV files, or a database, or also, any kind of files, really. But what we do is we want to take this data and we want to run it somewhere in the cloud, and that's shown by this, what I'm calling a web application in the little cloud. And in there, that web application can do really anything it wants. So here I just threw a figure that I had on my computer to show maybe in this case we're doing some sort of data visualization or analysis. But one of the key components that make all this work is what we call web app connectors. I've just called this a connector, and it's in red. But what it does is it's the interface between HydroShare and wherever these web apps live, and they can live anywhere. And I think that's a really important thing to remember, is that web applications like the compute environments I'm going to talk about today don't live on HydroShare hardware. They're not touching that data. They live somewhere else entirely. So let's take a closer look at this web app connector. Well, guys, this kind of, this will take a deeper dive in the web app connector, but also kind of shows what I was explaining, that these live in totally different areas. It might be a little hard to see, but this green box, all the stuff in this green box on the left-hand side of the slide is really what HydroShare knows about a web application. And if you've poked around HydroShare, you may see on our apps, I think, the menu bar or menu item called apps, there's all these little panels. And if you can see my mouse with MATLAB Online, JupyterHub, Hydro Client, Data Series Viewer. These are kind of just ways of launching these applications. They're just really buttons, that's about it. But what they are in terms of HydroShare is just its own special resource type. And the resource type is called Web App Connector. On the left, or kind of way behind everything over here, this is a screenshot from a portion of a HydroShare landing page for a Web App Connector resource. And it's really kind of a meta resource in a way. It doesn't have data associated with it. What it does have are things like supported resource types, which are the types of files, for instance, that it might be able to operate on. Like, for instance, if you had something that was to visualize vector data, it would only make sense for vector formats. It wouldn't make sense for non-vector formats. So that's a way of kind of catering the app to specific types of use cases or files, really. It also has this web app launching pattern. And this is this is how HydroShare invokes or instantiates these different web applications. If you are not creating a web app, then this stuff doesn't really matter. It's good to know that it exists, and also know that there's, of the 8 web applications I'm showing up here, these are the ones that are kind of what we call quasi-approved. We know that they work, we vetted them. There's a whole bunch of community developed web apps that you can just find in the Discover page. So on the HydroShare Discover page, I just filtered by web app resource type, which is one of the facets on the left-hand side of the page. And I get this list of all these different web applications. And here we even have a duplicate of sorts. But really, these can be owned and created by anyone. It's just a way of connecting HydroShare to something outside of HydroShare. So the left-hand side is what HydroShare understands. The right-hand side, and this is where I was getting at, it can live anywhere. The web applications here in this red box, it can live anywhere, and it can do really anything. This is a snippet from the Jupyter blog that shows how someone might configure JupyterHub using Kubernetes to orchestrate the creation and balancing of virtual machines, right? We actually use a bit of this technology for our JupyterHub, but this is a pretty complicated system. Apps can also be very simple. It could be something that's just designed to look at CSV data and plot it. It could be very, very lightweight, and it could be pretty heavy and complicated, like the one shown here on the right. And I guess I want to pause here for a second and just give anyone an opportunity to ask a question if this is unclear at this point.
Yeah, I got a quick question for you.
Yes.
Who is this generally intended for? And is it intended for the users, or are we building tools for the users ourselves?
Yeah. Yeah, so I'm kind of diving in a little bit too deep here initially, but this is what, if you're creating a web application, you would care about this launching patterns, all of that stuff. You would care about the stuff on the right because you have to create the app. But from a user's perspective, we just want to know that these things exist, and they can be found on the Discover page, which is this box down here where you can just search, or on the app's landing page.
Yeah,
and then I'm gonna,
top part on the HydroShare.
Right.
But I was trying, I'm trying to figure out, can we build tools that fit then within the resource that they could use, or how is it best to utilize these? Or
it really depends
how to do it.
Yeah, it really depends. So there's no need. Nobody needs to develop a web application. These things exist and they're free to use for the most part, right? There's some rules for certain apps. We'll get into that later, but using them, that's the whole purpose. If someone like myself develops a web app, registers it on HydroShare, and then someone can use it and operate on their data. If there is some special functionality that doesn't exist, or some tool that your team or some group of people want, then it's up to them to really create that tool.
So if I talk to my PIs, for example, and they have a particular need, I could go build the tool for them and just create a link to that tool.
Yeah.
Or they can just figure it out themselves. I mean, that's always option 2, I suppose.
Exactly. Yeah. But that's about as far as I'm going to get into like the nuanced details of what an app is. We're going to take the following slides. We're going to look at how a user would interact with them.
Okay, great. Thank you.
Any other comments or questions before we move on?
Yeah, so in terms of what we're trying to do ultimately is have our data live on HydroShare and have some sort of interface that our PIs can use to graph the data and visualize it. The very simple graphs, basically X, Y, whatever it is that whatever variables are in those data sets that they want to plot. So what would you say from a development, is there something in there that we could take and edit already to do that? Or is that an application that I'd have to build from scratch? Or what would you, I see this thing called data series viewer, which I don't really know what that is, but what would you recommend for some construct like that?
So the data, the data series viewer is actually specific to plotting data that's in Quasi's hydrologic information system. So that might not work for you.
Now, it works on data in HydroShare as well. You can, if you have time series
does.
data stored in your resource, and it is automatically aggregated, you can open it in the time series viewer, and it will open into a visualization of your data of up to, I think, 5 different time series overlaid on one plot.
Yeah, that's
So that
piqued my interest as well.
So these are,
so that might be something that'll work. So that also, so there are some caveats there. Thanks for the clarification, Clara. It operates on time series aggregation types, which means that your data has to be converted into time series aggregation, which means it has to fit the model of aggregation, which I believe last time I looked, and Clara, correct me if I'm wrong, is an ODM2 data model.
It has to be an SQLite file. I'll send the help pages to the chat.
Yeah, so a SQLite file, it's a file-based file database. And I think the schema inside is ODM2. So it's, and this is actually something that Jeff Horsburgh worked quite a bit on. This is the time series resource, but just simply plotting a CSV file, for instance, or tab separated file or something like that can be done in like the Jupyter, MATLAB, other kind of computing environments. If you're trying to read data from very specific sensors or data loggers or something, I don't think we have anything out of the box that'll do that right now.
well, we're trying to build, I'm building it's a simple, but 2-table relational database that is going to be right now in SQLite. So that's what that's what I think I'm going to store in HydroShare to access through that. But in terms of these different things, whether it's the data series viewer or how do these work? Like, is there just a default code that you then go edit to point to your resource, or how does it, what level of application development does somebody have to be at, I guess is my question in order to.
It's most likely kind of advanced. So if your web application is going to do some sort of visualization of a format of your choice, it's going to fit in this red box. You're responsible for any logic and hosting anything. So this thing needs to exist somewhere and you need to take care of it. The connection with HydroShare happens through the HydroShare API. That can happen. We actually have a lot of documentation for that, and we can help out with that pretty easily. There's ways of pushing data from HydroShare, or rather pulling it from HydroShare into the respective web application. But all of the logic for building these web applications is completely up to the developer of the app. That includes the technologies that are using it. Could be something simple. It could be an R-Shiny app or a Python Dash app. It could be an entire Django web server or Kubernetes cluster. So it could be very simple to very, very advanced. But that is 100% on the developer of that app.
Okay, thank you.
But we can, and I'll talk, we'll have some time at the end. We can talk a little bit more about this, and I'm happy to talk with anyone that's interested in building an app offline, because there's a lot of other information we probably want to speak about, which we probably don't have time right now. All right, so let's take a look at how these work from the user's point of view. So great, these apps exist, and we can launch them, but sometimes it's not very exciting to launch them unless you have some specific type of data that we want to work with. So here I go that one resource, this LQSEZO data set that Miguel Leon put together. You might notice in the top of resource landing pages, there's this open with button. If you click on that, it'll show you a list of different apps that might make sense for your resource. They might not make sense. In this case, I have, actually this one doesn't have data. I think it has a Jupyter Notebook. So a data series viewer, threads data viewer, those two don't make any sense. It could potentially make sense in MATLAB Online, but not really. Quasi JupyterHub is for Jupyter Notebooks. The CyberGS Jupyter for Water is another implementation on a high-performance computer by our colleagues. Would also make sense. So this up here is really just a guideline. It's a suggestion of things that might work. It's not always a definitive. It'll absolutely work perfectly in all of these environments. But that's one way of discovering what types of web apps might make sense for the resource you're currently on. The other way is if you just scroll down to the data or the content, you might right click on one of those files and you'll see other apps that might make sense. If you had a GeoTIFF file, you might see something here for visualizing a GeoTIFF. When I right click on this IPython notebook, which is a Jupyter Notebook file, I don't have anything for visualizing raster vector data because it doesn't make any sense. So just those are two primary ways that someone might interact with these apps. You find your data, you click open with, and that it'll show apps that make sense. And when you open with, what the idea is the entire chunk of data in that resource is going to get moved into whatever that app framework is. As opposed to clicking on an individual file, it would just move that single file. Okay. So another small detail is that specifically with cloud computing related applications, and I'm talking about two that Quasi hosts, the Quasi JupyterHub and MATLAB Online. Both of these are interactive computing environments that give you free compute cycles and free persistent data storage. They require joining a HydroShare group. In this case, it's the Quasi Cloud Computing Group. Once you're a member of this, you'll be able to access these different web applications. And the reason why this is designed this way is to prevent misuse of the system. In the past, well, actually all the time, people are trying to gain access to Bitcoin mine and do other things. So just an FYI that if you try to use some of these apps, you might get redirected to a group page saying, hey, join this group first. And what that allows us to do is, well, you would be able to request to join the group. And then people like myself and other web app developers and maintainers can look through and say, oh yeah, no, this is a legitimate person, I'll let them join. Or this looks like a spam account, I'm not going to let them join. Another thing I want to point out, and this is true with all apps, is that disk space is not shared with HydroShare. This is a very common misconception, and it rightfully so. You're in HydroShare, you launch a web app, and like, where exactly does my data live? A lot of people think that you have HydroShare and then your My Resources, we'll call that like the data in HydroShare, exist. And when you launch these apps, you're directly operating on your data. But this is not true. Okay. So what actually happens is you have your HydroShare and your My Resources database, or your My Resources data. If you were to launch something like Quasi JupyterHub or MATLAB Online, your data gets, the data that you are operating on, like the resource you're working with, gets copied into that environment and saved in its own respective data store. And when you leave and come back, your data is still going to exist in those platforms. That's the persistent data that I mentioned a minute ago. So everybody, for both of these platforms, I think every user is given 10 gigabytes of space to store files. If you want to move that data back into HydroShare, you need to do so explicitly. You can do that by downloading the files and uploading them to HydroShare, or you can use some of our built-in tools. So for Jupyter, Quasi's JupyterHub, we have the HS client, which is a Python library for working with the HydroShare's API. We have HS tools, which is a command line utility that wraps HS client, so you can do simple little commands. And most recently, we have HS on JupyterHub, which is a graphical user interface inside of JupyterHub to help you move your data around between HydroShare and JupyterHub. In MATLAB Online, we have HSM tools, which are a set of, it's a little miniature MATLAB toolbox that does basically the same thing that HS tools does for JupyterHub, which is just command line functions for sending data and querying data. So you can download data from HydroShare into your space, and you can move it from your computing space back into HydroShare. But just keep in mind, when you launch data from HydroShare into some web application, you're getting a copy of your data. There's no shared, like physically shared data. There are ways to accomplish it, but I don't think any app right now is doing that at all. And it partly because it's problematic. What if you edit it in file in HydroShare and you save it, and then you're messing around with it in the cloud computing or whatever app, and things get out of sync? You have to be able to resolve that, and there's a potential for data loss, and I don't think most of the app developers and maintainers don't want to touch that at all. Okay, So I'm going to talk real quickly just about this JupyterHub because I think that might be something that might be useful for you guys. When you launch the Quasi JupyterHub through a HydroShare resource, doing the open with, or just going directly to, or clicking that big button, or going directly to the URL, you're presented with this interface on the right, where you can select the type of computing configuration that you want. And the purpose of this is to help to assist in data analysis by having pre-configured libraries like software programming languages, even compiled models already pre-installed and set up. So there's not that there's no need to install things, but there's limited need to install things. So a couple I want to point out: Python 3.8. This is kind of a standard scientific setup for Python version 3.8. It has all sorts of fun libraries like, pandas, scipy, scikit-learn, gdal, xarray, those sorts of things. And then we have R 3.6.1, which is the R programming language. And that has a variety of libraries as well that are kind of aimed at scientific, just general purpose scientific analysis. Those are the two most popular environments. And then we've been experimenting with some slightly different environments. And the first one is for a specific model that is being developed by some collaborators on the HydroShare project called Summa. So we set this up for exploring how to use that model in cloud computing world, as well as Work Hydro. And then finally, the CSDMS workbench is actually something we put together for a somewhat recent workshop that was held by the community service dynamics modeling system. A couple of things to highlight. I mentioned the pre-installed and pre-configured libraries, but persistent storage, you get about 10 gigs to store data. When you edit files, you leave, you come back, they're still there. They haven't disappeared. That's the point of that. Free compute cycles. We are not charging anybody for this. You are limited in how much hardware you get. You'll basically be given a kind of a desktop in the computer. You're not getting an HPC or some kind of high performance configuration, at least. You're not getting GPUs or anything like that, because it's a pretty expensive and tall order to give it to the whole community. Not that I don't want to, but. And then there's also tools, like I mentioned, for moving data between HydroShare and in JupyterHub in this case. So this has been used in a variety of ways that may be interesting to some of you. I've used it quite a bit for educational purposes in both workshops and in our summer institute. And here's one particular example for playing around with the national water model data, where we subset the data, we collect and regrade forcing data, and then actually run a simulation in the cloud. And one of the really cool things, if you have an analysis or a workflow that requires special configuration, then none of the workshop participants or students need to install anything. You can focus on kind of teaching the concepts or focus on the analysis. Sometimes it's even great for stakeholders. You can get them hands-on without saying, oh, by the way, do you have X, Y, and Z installed, and you need to compile this? What OS are you on? You don't have to deal with any of that. We've also been exploring how this can be used for reproducible science. So I'm sure you guys have heard quite a bit how HydroShare is being designed to support the publication of data, specifically publication, and then referencing data in presentations and papers and such. This is an example of some work that myself and some others did in 2019, actually, creating workflows and Jupyter workflows and linking them to our paper and publishing it, so that people can read the paper, go to the actual resource in HydroShare, launch it, and go through the analysis. And I say HydroShare plus JupyterHub is approximately reproducible science because there's a lot of caveats here. You upgrade the JupyterHub system or the cloud computing system, and a library update might break these notebooks, so it's problematic. So this is kind of, encouraged us to pursue this avenue a little bit deeper of how do we actually support reproducible science. So what I'm showing in this is our last slide. It is just ongoing work. It's not really ready for anyone to use yet, but just to give you an idea of where we're going. I guess this part you can use. If you were to go to mybinder.org, there's actually an option to, and there's a little drop-down list to specify HydroShare resource. You pass a HydroShare resource ID here, and you say launch, and it will build an environment and stick your data in it in mybinder.org. So if you're not familiar with Binder, Binder is a technology for building containerized environments on the fly. So it builds this containerized environment, then drops you inside the environment in a Jupyter Notebook. It's really cool. So we, Scott Black actually is a developer who, he's a software engineer at Quasi. He actually implemented this. It's really, really cool stuff. You can test this out on your own. And actually, if you put Binder build files in your HydroShare resource, which I can talk to anyone about that offline, if there's interest, you can build a very customized environment on the fly. So what we started exploring is how can we extend that to our own computing, where we can provide maybe better hardware for some kind of larger study that needs more than a very minimal hardware configuration in the cloud, which you get at mybinder.org. So we came up with this kind of an approach where we use things like Google Container Registry and Jupyter Notebooks, a directory of Binder files and metadata associated with them, where we can launch it in our own hosted Binder hub and run these the analysis. So this is actually something we presented on at AG this past year, where we took a model, the RESA's model, and built an entire environment to run this model so that someone could replicate a study that was done. And that was kind of taking, going from HydroShare directly into running and analyzing the results of a hydrologic model simulation. Okay, so I'm going to stop here. I think it'd be good to do a demo so we get a better idea of what the heck I'm talking about. My contact information is right here, acastronova@quasi.org. I'm happy to field any questions offline. Also, the Quasi Slack channel or whatever. But I can go into much more depth. We can have a discussion going into some like the nuanced details or more depth than any of those kind of web app development and how it's connected to HydroShare details there, if anyone's interested. So let me stop talking for a second. And if anybody has any questions, we can answer those, and then I'll go on to a demo and we can get hands-on.
So I have a question that's more of a side topic really, but you talked about that there's no availability to look at raster or preview raster stuff in a resource. Is there any plan to develop anything like that?
No, I think there might be actually. There are I was saying in that particular case, it wouldn't make sense. That's why it didn't show. In the past, we did have capability to view GIS data. I think some of that was under development. I think we may have moved directly towards visualizing using like web map feature and coverage services. So that would enable you to view in like Arc Online or something. I'll have to check up on the spatial data visualization. I'm not up to the speed up or up to date on that.
Yeah, I think in general, I like that. It'd be neat to see more tools like that. I think there's a lot of power in those.
Mm-hmm.
Thanks.
Yep. Okay, let's go take a look over here. Okay, so this is the resource that I was showing. And again, this is not something I created. This is derived off of Miguel Leon's notebook that I made some modifications for a quick demo. It only contains a Jupyter notebook. I want to do something with this, right? If I right click on this, I should be able to, I could probably view the notebook. I haven't tried this in a long time. This should redirect to notebook viewer, mbviewer.org, and it just renders the notebook. So we can see what exactly this is doing. It looks like we're just going to visualize some data. So let's do it. Now, say open with, I'm going to choose the Quasi JupyterHub because that's the one I'm going to demo today, but you could kind of test it out in some of the other ones. And what happens, and you might see here, I'm already logged in. If I wasn't, it would ask me to log in with HydroShare. And then it would check to see if I'm in that Quasi Cloud Computing group. And if I'm not, it would redirect me to that page and say, can you please join this group? And then you just have to click, can I join the group? And then someone like me or there's a team of us would approve you. I guess I'm going to run this in the Python environment, but this R environment is actually kind of cool. If anyone develops an R, it actually gives you an R Studio interface, which is kind of cool. But let's open the Python one. What's happening right now is I'm getting a Jupyter instance on a server in Google Cloud right now that is completely isolated from everyone else. So anything I'm doing, or if someone else is on the same machine as me, nothing they're doing is going to impact me. Like they're not touching the same memory space. We don't have the same disk space. We're completely separate. Yeah, that's about it. The only thing we do share is total memory and total CPU like availability, which is already capped off. So each user has a maximum CPU and a maximum memory, and then we provision machines so that X number of people can fit on them without fighting for that. So you share it, but there's no way of impacting other users on the system. So because this is being created on the fly, it can sometimes take a minute to create the resource or create the space. And I guess I should say right here, oh, that went really fast. What happened there is my data got pulled over. And actually, since I already have the data, it didn't replace it. But what happens there is you got placed in a JupyterHub environment, and then we went and grabbed your data and grabbed my data and dropped it in JupyterHub. So now I have a copy of the data in JupyterHub that should be the same. It could differ, but it should be the same as my copy in HydroShare. It would differ if I've already played around with it. In this case, I have. So let me go ahead and just click on that LCZO preview notebook. And since I've already played around with this a little bit, I'm just going to clear all the output. So there's a few, we're given a specific, or we're given a pre-configured environment to work in, but we can actually still install tools and libraries. If I were to do like pip or conda to install Python libraries in the root environment, when I leave and my server gets shut down and I start back up, I would have to reinstall those because it's always going to start from like a snapshot, essentially, like its own initial starting point for the environment, a clean environment. But I can create conda environments, and this is something I can point some documentation to that we've created. These conda environments will persist. So here I have an example. I have some instructions for someone that's new that wants to run this notebook. Here's a suggestion: create a conda environment, in this case called ODM2, using Python 2.7. Oops, because there's a Python 2.7 dependency in this particular notebook. Then we want to activate it, and we want to install ipykernel. Now, once you do all of that, your environment, anything you install in this environment will persist also, which is pretty cool. So you can actually install libraries you need, leave, come back a week later, and they're still installed. In this case, I have to install ODM2 API, which has the Python 2.7 dependency, and I want Folium as well. So let's just step through real quickly. In this case, we are just loading some libraries, which seems to be taking a second. I'm not entirely sure why. And now I'm downloading a different file. Okay, this is the HS tools library I was talking about. So I can say, oh, there's data that lives somewhere else in HydroShare. Go grab that for me. And what we'll see here is that the data actually lives right here. Now, this already showed when we originally launched, it did show this data here because I had launched it immediately before this this presentation, but it wouldn't have if I didn't do that. And if I click on that, I can see that this is a HydroShare kind of bag. And in here, I have a SQLite file. Oh, didn't want to click on that. A SQLite file. So this is an ODM2 SQLite database. All right, let's go back. So I've downloaded it, and now I know my database path. I'm going to create a connection to that SQLite database, and I can preview some data. So for instance, we can look at all the variables that are in the database. We can look at all the people that are registered in that database. And we can also plot some data. So let's go ahead and plot something. Here we're using Folium. This is in Puerto Rico. Oops. And you can create interactive maps here. So here we have an observation well. Okay, this one's a stream gauge. There's one I'm interested in, the El Verde field station on the rooftop. So there's a weather station. So if we preview this data, which is what I'm doing in this cell right here, we can see all the different time series that exist in here. And if we scroll all the way over, we should be able to see some variables. And this is what we'd expect from a weather station. So let's plot some data. So here, what we're doing is just plotting a few of the variables. So ripping them out of the database and creating a plot. And we can make this as interactive as we want, but this is an example of maybe just previewing some of the data that exists in HydroShare without having to download anything. If I wanted to manipulate these data and save them back to a new HydroShare resource, I can do that. That's where this HS tools library comes in. If I do ! HS, it should give me some help and tell me what it can and cannot do. So I can create, so I can do HS create, and I can do -- help, get more information on how to create. Okay, I'm gonna have to abstract the title, keywords, the files, all sorts of things. But this is one of the ways that we can save data back. There's another resource I wanted to show, which I've already downloaded. I've already done the open with quasi JupyterHub. So what I'm going to do is just show you another way of looking at these data. So the GWT is 6831. So if I go here and I want to switch to a slightly different view, the default view for opening up JupyterHub is actually what we call Jupyter Lab. And it looks like this. We can see what it looks like, and it opens up. However, the default view for launching data from HydroShare to the quasi JupyterHub is the old notebook view. This is something that we're in the process of changing right now. So there's a little disconnect, but this is the environment that is default for the most part. So this is kind of the one to maybe get most familiar with. Well, this is all the data that I have in my JupyterHub. In downloads, all these different GWTs, these are all the things that I've downloaded. So if I wanted to look at the LCZO preview, it's CEF0. I can come on in here and find CEF0 and just double click on these until I get down to LCZO preview. Let's get rid of that one. And it's the exact same notebook, right? We can even see the code that we just ran. So since I'm in this nice view now, I'm going to go into downloads, and this one was 6831. Okay, watershed delineation. And I'm going to show this partly because Eric, you mentioned something about visualizing rasters. This I've already executed all these cells because it does take a little while, but this uses TauDem. If anyone's familiar, that's a JS process or raster processing library developed by Dave Tarbotten at Utah State University. And here what I do is I take some raw DEM that covers Logan River, the Logan River. And there's the DM. So it's just a quick visualizing it. And then we can run all sorts of different commands, even using MPI to distribute over a number of cores. So in this case, 4, to calculate things like flow direction and slope, using a couple different methods, contributing area, scroll all the way down, eventually getting a grid network, and then stream delineation, and there we go, watershed delineation. So watershed delineation. So that's one way that we can play around with like raster data, for instance. And the very last thing I'm going to show, and I'm sorry I'm going kind of quick because I want to leave some time for us to step back and talk about these. Jeff had mentioned that it might be nice to show that we can develop interactive things in this environment too. So let me show you something that I created for this demonstration for something called Water Hack Week. So we had an event, a 2019 event, which is a week-long hackathon around water science data. And that's when COVID got delayed because of the initial onset of COVID, and we ended up holding it virtually. So we did a little tutorial to show, it's actually already open, show something that you can do. You can build kind of interactive web apps in this JupyterHub as well. So what I'm going to use is the Boca library, and load all that in there. And and I create a web app. My web app is actually defined in this cell right here. This is the entire web app. That's it. It's not that much. So I'm going to execute that. I can download data, which I just downloaded earlier. But this actually is COVID data that was collected by Johns Hopkins. So just go ahead and grab that. And then I can run this cell right here and actually create kind of like a widget. So in this case, we were looking at confirmed cases of COVID and confirmed deaths from COVID. And just looking, we can plot things in various ways and take a look at what they, lines, bars, whatever we want. But you can create interactive widgets, we'll say. And these widgets could, in here, it could have a cell where we say, oh, go grab this data from HydroShare and let's visualize in a variety of different ways. So this gets towards what I was talking about, that the web application can be very complicated, and this is definitely on the more complicated side. Or it could be very simple, and it could even be just something that you kind of create inside of a web app. Except you wouldn't have your own web app connector. In this case, you'd just be in the JupyterHub because it runs inside of JupyterHub. All right, I'm very sorry for giving so much information in such a short amount of time. So I'm going to stop talking again, open it up to questions. I'm happy to, we can tinker around together for the last 15 minutes or just field some questions, whatever is most helpful for everyone.
So I'm just thinking about my users here. I guess one concern I have is a lot of these tools require certain technical knowledge, and sometimes people just don't want to spend a lot of time just to preview data. Is there any other options in the mix?
Well, I mean, so with the
or something quicker, yeah.
I mean, there might be. We could take a look at HydroShare. What's registered in HydroShare. The cloud computing resources, this and MATLAB Online, are specifically designed for people to write some code, right? If we don't want to write any code, then yes, they may not be the right tool. Something like this COVID notebook could potentially fill that, but it's still a little bit technical.
I would say that if you, Eric, if you were gonna say that you wrote a notebook and all they had to do was hit run on the notebook.
Yeah, that's what I was thinking, developing to try and enable people to be able to do it a little simpler.
Yeah, I mean, like there's plenty of notebooks that I've used of Tony's, for example, where I just opened it, read it, like, and just hit run and it did whatever it was supposed to do. So if you can kind of set them up in that way where all they have to do is hit run and then they can visualize your data and the markdown will render and all these different things, it can be a really powerful tool also for like making it feel less scary also to interact with.
But I'm nervous about it. People are like, oh, this is too complex.
Like, oh, it's code. I don't know how to code. But like if you can set it up so all they have to do is hit run, then it also makes it seem less scary, but you've developed the tool for them.
Yeah, I think that's a really good point, Clara. Like this COVID notebook, for instance, there's ways of creating widgets. There's actually a Jupyter Notebook widget, I think, library, where you can hide all the code. So the cells exist, but they're hidden. And it automatically executes them, and it just shows you the one thing. And then the other thing, just to tag on or to follow up to what Clara was saying, that this notebook, for instance, was designed to show someone how to use the library. But even still, someone can just go ahead and say run and say, just run all the cells for me. Like, I don't care. And then they just scroll down. In this case, this file folder already exists. So I wrote some bad code here. So it broke instantly.
Good demonstration.
Yeah. Here, we'll run from all the selected cell and all below. Okay. And hopefully we start seeing some things pop up.
Yeah, regardless, I believe you. Clearly, if we built something, we'd be testing it, making sure that it ran smoothly. But yeah, because I mean, there's a certain degree of ease that people want, especially when they're just trying to preview the data before they download it.
Yeah.
And so I'm always looking to create a resource that way.
Yeah. I think, I mean, what we could do also, what I would, I guess, encourage you guys to do is go to before you develop anything. So if we go to the Discover page and scroll, scroll all the way down. I'm going to filter based on this web app. So there's 46 web apps that exist. Okay, so we can try to look at any of these. Here's the data series viewer, right? Quasi JupyterHub. So I mean, you could kind of look through and try to figure out if there's anything that exists that's going to kind of meet your needs initially. The big lift though is if you have a standard set of operations or analysis or visualization that's going to be applied to kind of a small subset of files or data sets, it might make sense to create an app. Visualization apps can be really tricky though, because it's hard to build a one-size-fits-all solution, right? It gets really onerous trying to deal with all these different edge cases and different data types and all that kind of stuff.
Yeah.
But if you have like, oh, we have different types of sensor data and we want to provide an interface for someone to do some QA on it, that might make a perfect sense, right? To create a very, very lightweight web application using something like RShiny or Dash or Streamlit or one of these other frameworks, throw it in the cloud, and then people like myself and others at Quasi can help you connect it to HydroShare so the data gets pulled over. But once the data is there, then whatever your code does, it does.
Yeah, I mean, we have a lot of pretty straightforward time series data. And so, you know, it seems like there should be something fairly simple to build that it's going to plot that out in a Python kind of way, but I'm not sure how to make that super easy for people just to preview the data and not, if they don't need to manipulate it at that point.
Yeah, if you just want to view data there, if you follow, okay, so time series. So these are resources that actually have time series aggregations, HydroShare time series aggregations, which you can read about in the help documentation. But what they are is it's a recognized file type. It'll peek in and look at the data that's inside this file. But I believe it doesn't. Yeah, this is actually a database. The SQLite file, it follows the ODM data model, so it's a relational database.
All ours are really CSV files.
Yeah, I think, and we should talk with Jeff because there are ways of converting into this format. And I don't have to ask him about that, but I would imagine that I should be able to open this with the time series viewer. And okay, log in with HydroShare.
Equal, right?
Authorize that. And let's see if it works. There we go. So this is a data visualization for a specific type of file. And it is kind of a very general purpose visualization. Like Clara said, you can see about 4 or 5 files or series on a plot at once. You can't really manipulate them at all.
But yeah, for preview though, I mean, it does the job.
You can preview the data. Yeah, it's really for previewing.
And that's kind of what I'm interested at this level, just because I figure if they're going to manipulate it, they're probably going to download it and they're going to do what they need to do, but they can see what they're getting before they go.
Right.
Yeah.
So like the JupyterHub might make sense, like if you had an analysis or a workflow that you wanted them to be able to do without having to install anything. You could configure that, drop it in the resource with the data, and then they could visualize the data. And then if they wanted to run the kind of like the processing on it, then they could run it in the cloud and they wouldn't have to install anything. That would be the way that JupyterHub might be used in that case, if you even wanted to use it.
Yeah, I want to make sure I want to explore more options as we go along, as we get more data. So that'd be great.
And I guess one last thing is that I did mention we have MATLAB online. So if anyone's a MATLAB person, this does give you a full featured MATLAB interface with like 40-ish toolboxes built in, the same connection to HydroShare. So that exists as well.
Anyone have any other questions?
A lot, but I think, Tony, I'll get with you I think I want to see what my users, I want to get a specific example of what they want to visualize, and then I'll probably try to meet with you at some point and have you give me some recommendations on what you think the best path forward is.
Absolutely. Yeah, this is a lot of, this is a very high level, a lot of information. Because I didn't exactly know what you guys were going to be, your use cases were.
John, I
Yeah,
also dropped some help stuff in the chat, like a YouTube video on the time series viewer and things like that. In addition to it, the best plan is definitely to talk to Tony. But if you wanted more information on like time series data and HydroShare, those links are in the chat.
Thank you.
So yeah, John, reach out to me, and Eric, same. I'm happy to talk with you also with some, to talk through some of the use cases that you have in mind.
Yeah, and I like John was saying, I'm trying to find out from my user, my PIs in particular, what their needs are going to be.
Mhm.
Thank you very much.
Yeah, no
Yep,
problem.
thank you.
Awesome. Thanks so much. Probably stop the recording.